you very much. Wow. Oh, I see. Thank you very much. It's amazing to be here. I want to invite you to walk with me to how we use Earth observation to analyze permafrost degradation and map drainage networks in Unalakleet, Alaska. My name is Javed Nazari. I'm an international student from Afghanistan. I'm a Fulbright alumni. And my teammates are Unalakleet, Clara Maxwell, and Daniel Marston. But before starting, I want to tell you a little bit about Unalakleet community. The native village of Unalakleet has been suffering so much from climate change effects. Their ice is melting, their permafrost is melting, the sea levels are rising, storms and floodings are surging, and this community, part of their planning, the resilience planning, they want to move inland to get away from these impacts. But inland, there are other questions for the inland. Inland has posed its own challenges. One of the challenges for moving inland is if the land is stable, because we have the problem of permafrost inland as well. And also, there is the subsidence of land. The land uplifts and goes down. They want to know how much that uplift is, that subsidence is. So we partner with National Renewable Energy Lab to measure and map this summer subsidence specifically. And also, to provide them the drainage network that are derived from digital elevation models. Our results, the subsidence map, are derived from Sentinel-1 data. There are current limitations with Sentinel, but that limitation are reflected in our work a little bit, but we're excited for the upcoming NASA and SAR. NASA at the moment does not provide SAR, but in 2024 we'll have SAR data, radar data, in a quantity and a quality that never seen before. So we use radar images, the kind of image they call SAR, we use to develop something called interferograms. Interferograms shows the displacement from one SAR image to the other SAR image. So we use all this information in a software called MinPy, developed by Alaska, in the Alaska Satellite Facility. We stack all of our interferograms in this software and use a network to drive the displacement maps for summer. Displacement maps are for each 12 days. For each 12 days, we measured how much ground is subsiding. And we remove the other other factors that may impact the radar, like topography effect and atmospheric effect, all the noise. We also use the digital elevation model to drive the drainage network and also measure and map the height above the nearest drainage. This slide shows our result for only 2 years, the summer 2019 and summer 2022. We drive the same result for the last 6 years. We didn't drive for winters because in winters you have the snow and that would affect the measurement. As you can see, 2019 experienced much more subsidence, shown in red. This is because we had a record-shattering temperature in that year, but 2022 image on the right was less subsidence, and that was because it was a cooler year. These 10 weeks, we could map the subsidence for summer season. There is a question of long-term subsidence, which might be more related to the permafrost thaw. So that leads us to our future work, to the future potentials. NASA, there's two future potential that I want to talk about here. One goes back to NASA and ESAR. There are going to be two band, L band and S band, that will be provided with NASA and ESAR. That's very useful. The CAN band that we use is 5 centimeters. 5 centimeters cannot show displacement more than 5 centimeters. It can show less than that, but not more. But NASA would have 20 centimeter wavelength of radio waves, which would be very important for us to have a better quality of data and drive the long-term subsidence. Also, there's a 9 centimeter that we can combine all of these together to drive a better product. And then I just want to thank of the people who made this experience possible for us. Our partners, our science advisor, Dr. Margaret Madden, Dr. Simon, and Dr. Zubek from the University of Alaska, Fairbanks, and Dr. Lulu from Woodland Climate Research Center, also our amazing fellow, Sarah Payne, and our team. I just want to say this at the end, that our journey with Develop has come to an end, but our zeal to explore Earth observation just has started. Thank you very much.